One of the first things we talked about were like maxes and mins, extreme points. So let's say I gave you a picture. Okay, and I call this point okay. So let's say this was your graph. What is the minimum possible degree of that polynomial? Well, okay. Save that thought. You're answering like the absolute min. I'm asking what would be the smallest possible power for this? 4? Does the end behavior match an even power? No. If it's even, your ends have to be going in the same direction. Why do you say 5, Cole?
One less.
If I look at this, it has 1, 2, 3, 4 turning points. The turning points are always one smaller than the degree. So if there's 4 turning points, that means the degree is 5. Another way to think about it, if you really get confused, I didn't put the xy axis on here, did I? But let's say if I drew the x-axis like right here. How many times does this graph hit the x-axis? And your degree is your x-intercepts. So if I drew my line there, it would hit 5 times, so it would have to be degree 5. We also know it's an odd because of the end behavior, so a lot of things that we could do to help with that. All right, what if I asked for local extreme points? That's asking for the local max and local min. Remember, these are your high and low points. They're your turning points. All your turning points either is a local max or a local min. So what would be my local max? Right, they don't have to be the highest on the entire graph, just higher than surrounding points. My local min. Good. What if I ask for absolute extreme points? MN. That's the highest on the entire graph. Now, careful. That looks like the highest, right? And it would be if this were like an endpoint over here. But it's an arrow. What does that mean? It keeps going up. If this keeps going up, do I have a highest? No. So just watch the arrows. Okay, do we have a lowest point? No. Now, what if neither of these had an arrow? What would be my absolute max? MN, my absolute min? XY. So just watch the arrows. You may or may not have those. All right, any questions about that stuff? We talked about end behavior. That's just drawing the arrows. So if I said this, for your end behavior, you're looking at the leading term only. So my leading term is the term with the highest power of x. So that's my negative 7x to the third. Okay, if you see an x cubed, what does it look like? Chair. But what does a negative do to that? Flips it. So my end behavior will be up, down. Okay, can I just look at this one and tell my leading coefficient? No, because it's multiplied, not added. When they're just adding and subtracting, you just take the leading one. If it's multiplied, we have to think about, what if I multiply this out? We have a 2x squared, we have an x in the next parenthesis, and we have x cubed in the last one. So altogether, that would give me 2x to what power? 6. So that would be my leading term. Okay, x to the 6 is even, so it's going to look like a parabola. Does the positive 2 flip it? No. So in behavior, how about? All right, you guys try this one. Don't say it out loud yet. Take a second and think about it. What do we think in behavior? Down, up? Okay. Since it is multiplied, we have to get our leading term. So if we think that's like an x cubed times an x squared, which is x to the 5th. Odd powers look like a chair. There's not a negative to flip it, so you guys are correct. Down, up. Do we need more in behavior questions? Okay. Next thing we got into, so that was really the first section. Second section, we started off with long division. So if I said, or not fine, long division, synthetic division. Okay, so if I ask you to find this quotient, what do we do? Right, how do you know it's positive 3? Right, so what makes this equal 0? Okay, then we do our coefficients, so 4, 3, -6, -2. 4 comes down, 4 times 3 is 12, times 3 is 15. Times 3 is 45, plus -6 is 39. Alright, does it mean we did it wrong if we're getting big numbers? No. 39 times 3, oops, 117, plus -2 is 115. So how would I write that? Remember, the power always goes down by 1. So since the original was x to the 3rd, this one will be an x squared. All right, what if I said, is x minus 3 a factor? Was x minus 3 a factor? You're shaking your head no. What does it mean to be a factor? If it's a factor, it divides evenly. So what should the remainder turn out to be? 0. What was my remainder here? 115. So if I'm asking you if it's a factor, I'm just asking, do you get 0 when you divide for your final remainder? Factors divide evenly. Make sure, what if I had said you were going to divide x to the 5th plus 3x squared minus 6. How would you set that up for synthetic? I mean, I didn't say what. By x plus 3. What would go in my box, that one? Okay, what would I put here?
1, 0, 0.
Okay, so don't forget zeros if you have missing powers of x. So we're okay with that? Final type of question, like what we were doing yesterday. So let's say -2 is a 0 of 3x cubed plus 5x squared minus 3x minus 2. Find the remaining zeros and factored form. So what would you do here? Okay. Since I need to factor it, we're going to start with our -2. We'll do our synthetic. Three comes down, times -2 is -6. And I get a 0 here. How did I know I was going to get a 0? I told you it was a 0. So if you get something else, fix it. Okay, go back and find your mistake. So this is 3x squared minus x minus 1. Oh dang, I was hoping it came out nicer. Shoot, I picked a bad example. That's all right. What would you do now? Slip and slide. Okay, unfortunately, does this one factor nicely? No, so what would we have to do? Quadratic formula. So the opposite of b, plus or minus the square root of b squared minus 4ac all over 2. What are these numbers? Is this the factored form or the remaining zeros? Remaining zeros. Okay. I probably wouldn't have you do factored form on one that didn't turn out like this, but can I change something to ask you another question here? Okay, so if I ask for remaining zeros, that's when you go ahead and solve it. Let's pretend, so just for the sake of review, let's say after your synthetic division, you had 3x squared minus 2x minus 1. What would you do then? Okay, so that factors into x minus 3, x plus 1. Divide our 3 back. So we get x minus 1, 3x plus 1. If I ask for the factored form, what else do I need? The original 0 I told you, let's pretend it was -2. So what would go in this parenthesis? X plus 2. Okay, so factored form is when you have all the parentheses. Remaining zeros, if I ask for the remaining zeros here, it would just be setting each of these parentheses to 0. So you would get 1 and -1/3. So zeros are just a number, factored form is with the x.